Alright, so guys, this is really basic. Something you guys should have picked up a long time ago. When we talk about isosceles, in an isosceles triangle, what do we know about the sides of the triangle? Two of them are equal. So we say that in an isosceles triangle, the sides are congruent. Okay, so let's go ahead and mark that on our model on here. So these two sides are equal. Well, what that also does is that it creates something called base angles. And the thing to know about our base angles is these two angles down here at the bottom of the triangle. And with those two angles, we call them base angles because the base angles have to be opposite of your congruent sides. So notice that we're opposite of the sides. Okay. So that's where your base angles are. So it doesn't mean it's always sitting there at the base, and they're opposite of your congruent sides. And then what's important though is to also mention that your base angles are also okay. Now, that's it. I really debate whether or not to show you guys examples or just basically say isosceles triangles, the sides are the same, two angles are the same. Okay? Guess what? If it's equilateral, what does that mean? All three sides are the same, all three angles are the same, which means in an equilateral, if all three angles are the same, it means all three angles are 60 degrees. And then all you gotta do, guys, is apply it. That's it. So if we take a look at example 2, which is a little more tricky. 54 represents something called a vertex angle. It's the angle that's not a base angle. How many isosceles triangles do I have in example 2? I have 2, right? I have a tall one and then I have kind of a wider one, right? I want to hear your suggestions on solving for x. Chris?
You figure out 50 180 minus 54, and then you figure out the other way, and you go that number divided by 2, you get the other angles. And then you take that and figure out 180, you figure out that angle, and you figure out the vertex angle, the next one, and you minus 180 from that, and then you divide that by 2.
Did you guys catch all that?
No, it's not.
Oddly enough, he's perfectly correct. Alright, so basically here's what it's saying. In order to find x, I have to first find my two base angles down here. If I can find those, I can use that information to go and find x. We'll show you a little shorter way in which you came up with x. Alright, how many total degrees in a triangle?
90.
180. Alright, so that's already 54, right? And these two angles are equal. Okay, I'm going to call these angles theta. Right, that's a Greek letter theta. So that means that basically, the reason I don't want to use x, I don't want to confuse us with variables. So that basically means that 54 plus 2 thetas is equal to 180. So how do I solve for theta? Okay, so that's exactly what Chris said, right? Subtract the 54 from 180. So I have 2 theta. It's equal to 126, which means that the theta is 63 degrees. All right, so this little angle right here is 63 degrees. Now, use the concept that you learned yesterday. Yes, I can subtract the 63 from 180 and get that angle. And then add up all three of those angles again and solve for the two x's, right? And then I think Chris, that was the approach that you were talking about. I could do that. But if I ignore this and look at it from a bigger picture, remember a lot of times in geometry, the hardest part I think for students is not to do the math, but is the visual, I guess, understanding, the spatial analysis skills. And looking at a complete picture and really zooming in and seeing exactly what you only need to see. With the 63, what you are effectively creating there, that's what we talked about yesterday, in terms of this triangle, what is that angle called? It's called the exterior angle. And what did we learn about the exterior angle? Kind of, you're getting a lot of vocabulary kind of mixed up. But what did we learn? Look at your notes from yesterday. What did you learn about the exterior angle? Caitlin?
The exterior angle is the sum of the two opposite interior angles.
There we go. So since this triangle up here is isosceles, if that angle is x, then this angle is also x. And since this is your exterior angle, that means 63 is equal to 2x. Therefore, x is 63 halves. So that's probably all as complex as it's going to get. Okay, well, basically what you need to know, the sides are congruent, base angles are congruent. That's pretty much it. Okay, the rest of the time you're just setting the equation based on that. Might have to do a little bit of problem solving. We did here on number 2. That's really the basis of the entire problem. You guys do have a homework challenge waiting for you on My Big Campus, as well as a math Excel assignment for our isosceles and equilateral triangles. And that's it.
Please don't erase that.
What do we got?
Why did you guys